and more in greater detail in this program. And now, without further ado, I'd like to introduce Sujay King Liu, the Associate Dean for Research in the college, who will introduce our first keynote speaker. Sujay.
Thank you, Shankar. Good afternoon, ladies and gentlemen. It is my great pleasure to introduce our keynote speaker, Dr. Paul E. Jacobs. Berkeley Engineering is understandably proud to claim Paul as one of our most distinguished alumni. He earned 3 degrees, not the same, bachelor's, master's, and PhD degrees in electrical engineering and computer sciences from Cal. And we are also grateful to him to serve in his capacity as as the chair of our College of Engineering's advisory board. Paul began his career at Qualcomm Incorporated, finding innovative ways to improve the performance of cell phone chips. He holds more than 40 patents for his groundbreaking inventions in wireless technology and is a recognized global leader in the field of mobile communications. Important developments that began under his direction include the first Palm operating system-based smartphone, adding GPS capabilities to mobile phones, and I made use of that to come here today, the Brew system, which enables over-the-air downloading of applications, QChat, a voice-over IP push-to-talk system, and Mirasol, which is an advanced reflective display technology. Now, as CEO and chairman of the board of Qualcomm, Paul is extending the reach of wireless technology even further into services that enable us to transact business, to teach our children, respond to emergencies, and to monitor our health. These innovations are helping to make an impact all over the world, not only in developed countries, but also in developing countries. So please join me in welcoming Dr. Paul Jacobs, who will speak on the topic Mobile, a Platform for Innovation.
Well, hearing that list of stuff just made me feel old. You know, it's actually a little bit sad when I think about being here at a conference named after Rich Newton, because he was just a great friend, and I miss him a lot. And I think he really did a lot to make Cal the place that it is, and Shankar's doing a wonderful job following. But Rich definitely made a huge impact on my life, and I'm glad to be here to, in some way at this conference to honor him. And we've, at Qualcomm, really been trying to do a lot of work with Cal. And we do it both by sponsoring research, by providing scholarships, and a number of areas where we're corporate partners of Citrus and the Sensor and Actuator Center and the Wireless Center as well. But the thing that I'm really excited about going forward is this idea that Shankar was talking about the swarms of different wireless sensors that might be embedded in the world around us, and that the phone will interact with, and that they will help us manage all sorts of things, whether it's our health or the environmental conditions in a building, or the electric vehicle that's driving down the street, or any of a number of things that this is going to have a fundamental impact on our lives going forward. And so to be able to work with the faculty at Berkeley on a center that will focus in on these issues about the idea that you'll have these connected devices embedded in the world around us, and therefore they're very persistent devices. And so we need to make sure they're very secure, and they communicate at very low power, and they protect our privacy while still giving us the information that we can act upon. That, to me, is something that Berkeley is almost uniquely situated to have that broad interdisciplinary look at how to make that happen. And so we're really excited about working on the Swarm Center, and look forward to a lot of great things that come from that. And it really does go along with the strategy of Qualcomm. So maybe starting from the very end about this notion of the digital sixth sense that I'll get into in a bit, but in shorthand, it's really the notion that the phone is going to interact with cyberspace and services that are both in physical and in cyberspace, and merge these two things so that it will be your sense to tell when there are things around you in the immediate environment that you can interact with or you can get information from. And it will also act as a controller, and it's kind of funny that I talk about that because they handed me this as the controller for my slides today. So I'm controlling the slides up here from a little wireless device. And but you can imagine that that will just extend to a very broad range of things. But if we look all the way back to the beginning of Qualcomm, we just started out really not with the idea of particular products, but the notion that digital communications theory was going to be an important thing. And at my father's previous company called Linkabit, we had worked on using digital communications theory for very high-value applications, so space and military systems, which could afford the cost of computation that was required. And I don't know how many of you got a chance to see sort of the history of computation down below in the exhibit down below, but it's really, you can really see how things progressed. And Moore's Law helped Qualcomm come into being because those applications of digital communications theory, which were restricted to high-value applications, all of a sudden became viable for consumer and commercial applications. And so, one of the first things that Qualcomm ever did was build a trucking system, a messaging system for long-haul trucks, which, by the way, 26 years later, we're still operating that business. And I mean, that's how far ahead it was. Now, finally, it's turning into a terrestrial data business instead of a satellite business. But it was really that idea. And in fact, the next vision of the company of focusing on CDMA came about because we were using CDMA technologies for satellite systems. And the story is that my father and another engineer were driving down the freeway after having pitched it to Hughes satellite systems and realized that, if you controlled the power to a cell site, you could use it for cellular systems as well. And the other engineer ended up doing an analysis, and after a couple pages of analysis, he comes down to this really incredible capacity improvement number, and he writes very pithily, if these capacity numbers are even close to being correct, this could be an interesting business. Turned out okay. I think he was right. Next, we had built this packet data system which carried voice, which was actually the first thing I worked on after coming back from a postdoc. And we realized, though, that we could do the internet on this thing. And this was back in the early 90s when the internet wasn't quite such a popular thing. And we actually put the internet protocols into the phone, even though at the time the wireless operators only cared about dial-up modem service. And so we built a thing where in the network there were modems, and on the phone there was a thing that accepted the AT/DT commands, and in between was TCP/IP, the internet protocols. And the next year we just pulled all that other guck off, stuck a browser on one end, and tied it directly into the internet, and that's sort of how we got the wireless internet. But we focused really hard on the wireless internet as a motivation, and it's this kind of overnight success that's happened recently took basically 20 years or more of our lives to actually build the underpinnings for. And so then from looking at the wireless internet, we went and thought, what does that actually mean to the device? And we came to the idea that the device really was going to be the most personal device for not just communications, but for computing and entertainment and productivity. And so we spent 15 years of our lives building microprocessor technology and graphics technology, and you heard putting GPS in the phone and all these kinds of things. We're super focused on getting all of these capabilities into the phone, and that vision actually is what's caused the company to be so successful right now. The market really came our way. It became a mainstream thing to think about that. And so now everybody gets that vision, and now the company, we're obviously still working on the previous visions of the company, but the new vision of the company really is this notion of digital sixth sense. And what does it mean? I'm going to talk to you a little bit more about that. But to even start off with, it really is no hype to say that wireless is mankind's largest technology platform. It reaches people in the most remote corners of the world, people who don't even have electricity. One of my favorite stories is that there's now some Chinese suppliers who are making solar panels that go on people's huts, and they charge their cell phone, and after they're done charging their cell phone and they got a little more power, they run an LED light, and so people get lighting from the fact that they had their cell phone. And the reason why this can be paid for is because people didn't have electricity at their hut. They had to go travel somewhere, pay somebody, leave their phone behind, get their phone later, and just the cost of all that actually paid for this very inexpensive solar cell or solar panel that they put on their house. So just amazing, this kind of reach. But if you think about the things that can be done with the phone, it's really an amazing force for good. Not just providing connectivity, but we're doing education projects, healthcare projects, public safety, entrepreneurship. You go around the world, you see many, many areas where having the connectivity, not just of voice, not just of text, but full-on data connectivity is really changing people's lives. And one of my favorite stories there is we did an app called Fisher Friend, which was in India where there had been a tsunami in Kerala and killed people and really decimated the fishing industry there. And so we worked with a local company. This was part of a corporate social responsibility program, and we built an application that told people where the fish were, what the weather conditions were, which market to take their fish to so that everybody didn't go to the same market and depress the prices. That app now, which started out as a free app and a kind of a philanthropic thing, is now actually being sold for 60 cents. And it's because the value is there. It actually raised the people's standard of living because they sold their fish for a better price. They found the fish much more easily, and so on and so forth, and they're much more safe. And so these kinds of things are just pervasive around the world. I mean, it really is a force for tremendous good. And boy, you know, the one thing that really brought this home was the Arab Spring and all the things that happened there with people using their cell phone, posting pictures to Facebook. You know, we heard stories of people taking pictures of snipers on rooftops and posting that so that people would know where not to go, how to remain safe when these kinds of things were happening. But imagine the change, the social change that comes about from people being so connected with not just voice, but the ability to show pictures of things like that and videos and to tweet and to do all these kinds of things. So really, really kind of an amazing thing. The other big change that's going on now, obviously, is computing, because I assume probably everybody in this room has a smartphone, and if you don't, you're probably about to get one, because it really has become the computing platform for the world. And if you look at the numbers, we're expecting that the installed base of smartphones will pass the installed base of PCs this year, this calendar year. And it's already been the fact that shipments have already passed since the last quarter of 2010. So this has changed dramatically, and now these devices are getting all sorts of capabilities in them. And you say, well, why was that? And what happened? And I think just the notion of the way that the PC was before, we called it a personal computer, but it really was, in some sense, not that personal. I mean, it was in a place in your house or your office. Other people probably used it. It was kind of, there were certain tasks, certain functions that you used it for. But when it came to the smartphone, I mean, this really was about a thing for me, very customized to me. I could do the things that I wanted. I get my entertainment from it. I'm connected to other people through it. I have that access anytime, anywhere. And I'll tell you, I used to, going back 10 years, come up and give these talks about the phone getting into this position. I swear I used to have to duck Rotten Tomatoes because people said, what's going to happen is Wi-Fi is going to be the disruptive technology to the cellular industry. That's going to go away. And I said, no, I actually believe that the phone is going to be the disruptive technology to computing. And I think that's, what's happened. And so it's a really interesting thing to see, to kind of live through that whole transition. And in fact, it wasn't such a threatening thing to Silicon Valley. I mean, you look where a lot of innovation in the mobile space is coming from. It's coming from this area of the world. And that's from the way that convergence actually did cause industries to come together for a lot of benefit. And so, if you kind of look at why did that happen? I mean, what were the fundamental things that really came together? Obviously Steve Jobs popularizing the iPhone had a huge, huge impact on the mainstream adoption of it. But there was an awful lot of fundamental underlying technology that had to be created to get us to this point. And there was technology around the connectivity. There were technologies that went into making the devices much more capable at low power and low cost. And then obviously the whole notion of the applications and the internet and bringing the fixed internet onto the wireless device, making it mobile, making it much more personal, making it much more location sensitive. And so let's just kind of look through those various components of it. I mean, obviously, connectivity is sort of the key thing. I mean, you can see that from the shift from iPods to iPhones as a good proxy. I mean, just being connected is super important. And I realized this a long time ago. Sujay talked about the first Palm smartphone. So I had one of these way back when, so 97 I'd say it was, that we had just launched, Sprint had just launched their first CDMA service in Hawaii. I was sitting on the beach in Maui, and I had my Palm smartphone with me, and I pulled up my search engine, which was Alta Vista at the time, if you remember that one. And I just typed in Maui sushi, and it gave me back the best sushi restaurant in Maui, which we then went to for dinner. And I just remember thinking back then, I had thought this sort of theoretically, but it became visceral that the connectivity component was so important. It was just fundamentally going to change from what was then a disconnected PDA to a connected smartphone. And the same thing is absolutely true. Connectivity is incredibly, incredibly important for computing. Okay, so what's happened with this? Well, if you look at the kind of numbers that are up there, I mean, we now have, people used to say, oh, is 3G important? Well, there's now 1.5 billion 3G connections out of that 5+ billion wireless connections that are out there. And there's another 1.7 billion that's expected to happen between now and 2015. And by the way, a large portion of those are going to come from the emerging markets. So in fact, in 2012, we're expecting that 3G net additions will exceed 2G in the emerging markets. So already that shift to mobile broadband has happened, and is, it's really an absolutely critical thing for these emerging markets to have the benefits of wireless connectivity. Well, so the other thing that's happened with connectivity is the demand has grown absolutely dramatically. And so, there's some, you see these kinds of estimates, 10 to 12x data growth, but we had a major Asian operator come into Qualcomm, say they expect 1,000x growth in demand. And how are we going to deal with 1,000x growth in demand? And this was over the next, I think, 15 years. So, there is more and more demand going on, and what that's caused is that the operators are forced to roll out the latest network technologies. And so you see these technologies rolling out very, very quickly, in fact. And so, I don't need to go through the numbers. You can read the numbers here. But these are all the various flavors, 2G flavors of technology, 3G flavors of technology, 4G technology here. And I don't know how many people are using LTE systems right now, but these are now rolling out, and it's subject of a lot of competition by the operators in the United States. So this is, LTE is going to be a fundamentally important piece, not because the technology is fundamentally more efficient than 3G, but it just allows us to get into other bands of spectrum and use wider bandwidths to get more data down to the device that people hold in their hands. And so we see, in many cases, you'll see LTE hotspots put in place, and then you'll also have 3G for much broader coverage out there. So really what will happen is that you're going to have fundamentally multi-mode devices out there, spanning all the way from 2G to 4G and including Wi-Fi. And that story I told you earlier about Wi-Fi, was it going to be disruptive? No, it's actually a complementary technology now, and I'll talk to you a little bit about that. But fundamentally, offload is a critical component of how carriers are going to manage this huge demand for data out there. Okay, so let's talk about the devices now. The devices have fundamentally changed. It was not that long ago that your phone had a black and white screen that was only alphanumeric. Didn't even have color. And I'm sure you all remember your phones didn't have cameras on them not that long ago. I still remember a trip I went on with a group that I'm involved with, and we were fly fishing in Aspen and sitting in the middle of a stream, and a guy caught a fish, and I took a picture of it with my camera phone and sent it back to his office. And this was before camera phones were widespread. The amazement of the people in his office that he could get a picture back of him catching a trout in the middle of a stream, that's just blew their minds. Now this is completely commonplace. In fact, we're unhappy if our phones don't have two cameras on them, one on the back to take pictures of other people and one on the front to take pictures of us. And it's just, now you expect I can, move my finger around, everything animates absolutely perfectly. It just works, fundamentally so smoothly. You feel like you're actually manipulating the data and the graphics yourself. And there's a lot of stuff that had to go in to the devices to actually make that happen. A lot of graphics technology, a lot of compute technology had to go into the device to make that happen. The other thing that's going on with these smartphones is that they are really taking the world by storm. If you look at the kinds of numbers that are out there and where they're headed, they are headed into those emerging markets. And so you can see the kind of growth rates that we're talking about, 40% cumulative annual growth rates for the lower end, kind of the sub 300. 300 is not even the right number. It's like 150 and below is where we're really going to see tremendous growth of the smartphone. And of course, the high-end ones are going to continue to grow, and everybody's going to still want the fanciest things, so they can say I have multi-core and high gigahertz processors and all this kinds of stuff. But fundamentally, getting this kind of capability into the emerging market, I think, is really game-changing. And so we see just huge growth for those kinds of things. Roughly 50% of the smartphones sold by 2015 are going to go into the emerging regions. That's up from about a third of the smartphones last year. And the reason is because we learned something. We learned that you don't just invest in the high end and let the features trickle down. You actually have to invest as much at the low end to create the integration to drive the cost down so that you can actually serve that lower part of the economic pyramid and get the benefits to people. And so we will see tremendous growth in those markets. And so what did we do to do this? Well, we, based on that vision that I talked about, we focused on this technology or this chipset called Snapdragon. And this picture, I like this picture because it's actually made up of a whole bunch of different devices with the graphic in it, which is why I showed it to you, just because I like it. But really, the thing that's really interesting about it is that what's happened with that is we've taken that notion from the low end and just integrated the heck out of technology. So these things, the most recent chip that I was just at our Analyst Day, and we were up there showing off new tablets with this new chip in it. And we're down to the leading edge process technology. So we're in 28 nanometer process technology, and we can put so much stuff in it. Has every single wireless technology that's in it, including some that haven't even really been launched yet in terms of LTE, TDD. Has stuff like GPS. Well, not just GPS, but now we have GLONASS receivers in there as well. So now it's got twice as many satellites to look at, and so it gets you even more accurate. It's got graphics processors now that are fundamentally the equivalent of the console graphics that you had not too long ago. Multiple cores of microprocessors, multiple DSPs. It's just got fundamentally all of this amazing technology on essentially one chip, which is why these things, the cost has gone down, the sizes, you're seeing thinner and thinner devices and so forth. So we really focused a lot on trying to drive that. And obviously, in addition to what's gone on the smartphone side, we also see the tablets growing well. And now up to this point, I would say tablets predominantly have been an iPad story. The Android tablets are out there. They haven't been quite as successful. But I think that will change, not just with Android, but also with Microsoft working on having Windows. So they're porting big Windows onto mobile phone chips. And the interesting thing about that is now your Windows computer will act much more like a smartphone. So Microsoft spent a lot of effort implementing a feature that's called Connected Standby, which means that when your PC goes to sleep, it will go to sleep like a smartphone, meaning that the power consumption goes down to a very low level, and every so often it'll blip up, collect your email and your Facebook notifications and whatever else it is that it needs to update, and it goes back to sleep at very, very low power. And when you touch the screen, boom, it comes on right away. And that, I think, is going to be interesting, because now you'll have a tablet with a full computing environment on it, the full web, all the stuff that you expect. So I think that's going to be a very, very interesting thing. I've seen the form factors. There are extremely, extremely aggressive form factors that are going to be coming out when these Windows 8 launches happen. So, and by the way, not just tablets, but notebook style. And then what I find really interesting is the convertible style, where it looks like a notebook, but you can pull the screen off and the screen acts as a tablet, and when you click it back together, you get the keyboard and a little bit more battery and maybe some more I/O and stuff like that. So really interesting things are happening there. Okay, so let's just focus on the applications now. One of the most important things that I think is happening is the rise of HTML5 and the notion that this is a cross-platform way that you will be able to see applications being written. And there are lots of applications already now that are HTML5, you know, Pandora and the Kindle app and various things where people are now using this kind of technology, which is a much more web-centric style of writing application. This comes from a guy who, you know, I did the Brew application environment, which was very much a write it down to the metal. Now, why is that possible to build great applications with web technologies? Well, because we are focused really heavily on optimizing way, way deep down in the hardware, using all those processors that are on there, the graphics processor, the multiple microprocessors, DSPs, if we can do things with the DSP as well to make this stuff happen. And so there's all sorts of stats up here about how much faster we've already made things just by integrating very, very heavily into the hardware and optimizing the HTML5. And by the way, you know, these things are not just going to be running applications, but they're going to act like little servers as well. So there's also that kind of technology that's coming about. And I'll talk to you a bit about how things will talk to each other when we do that. But in the end, where do we think we're heading now? And I find it funny that I actually show slides with a washing machine on it. I mean, Qualcomm and washing machines were not exactly what I thought about when I started working there. But really this notion of all these kinds of things being connected, and Jan Rebay always talks about, you know, the 1,000 radios per person. And, you know, this is, if you don't get one in your washing machine, then it'll be 999 radios per person or something. But, you know, you're going to have all these kinds of things that are connected around you. And fundamentally, it's really an evolution, because the evolution of the wireless industry went from the ability to connect to the ability to consume, meaning that I got my entertainment and that stuff, and now we're moving to this notion of control and sensing of what's around us as well. And so some of the ways that will change the world, one of the areas that I like a lot is mobile health. We all know that we have this issue of the cost of health care is skyrocketing. It's going to bankrupt us as a country if we don't figure out how to manage the costs. We have the age wave, so populations are aging, doctors are aging with them, so there are fewer doctors for more patients. We need to keep people well longer. We need to improve the productivity of the doctors that we have. And the best way that we can think of doing that is actually closing the loop by having you be monitored and sensed, and this actually works. We have a company we've been working with called CardioNet, which does cardiac arrhythmia monitoring, and right on the device, it actually runs algorithms to figure out, is the heart rhythm right or wrong? Is there a problem? And if there's a problem, it contacts the monitoring center, and people take action, and they can help you. And in fact, that's even happened. There was a guy sitting in a bed in a hospital, and his device went off, and they said, you need to get to the hospital. He said, I am in the hospital. They said, well, then ring the call button and get the nurse there quickly because you've got a problem. And literally saved the guy's life. And right now I'm actually wearing a little device on my arm that's monitoring my calories, my activity. It tells me how I sleep at night. I found out that I'm only a 78% efficient sleeper because I wake up and roll around for the rest of the percentage of 22% of the time when I'm in bed. But anyways, just as interesting stuff. And you think about monitoring chronic conditions like diabetes. There are things that are even more far out. There's researchers that are talking about injectable sensors because, for example, 24 hours before you have a heart attack, things start flowing through your bloodstream that actually are detectable. And so if you had this sensor monitoring your bloodstream and be able to communicate to a device, and the device can tell what's going on, and it could alert you ahead of time before any damage happens. So all sorts of really, really interesting things going on the wireless health side. Part of this is going to be enabled by new radio technologies, and one of the radio technologies we think is very important coming up is personal and body area networks, meaning things that will allow sensors that you wear on your body at very, very low power to talk to the phone that's in your pocket, and then the phone with the bigger battery can now talk off into the network. And we're building technologies that incorporate things like ranging. So if I'm, for example, a nurse brings an IV bag to a patient, the IV bag might have one of these devices on it. It knows that it's at the right patient instead of the patient that's across the room. And you would be scared if I told you how many IV bags are actually incorrectly delivered to people. It's actually frightening. It's something like 30% of IV bags have a medically significant event because they are wrong. And if you can just detect that you went to the right patient or the wrong patient, that right there will save people's lives. And so we're doing this stuff. We've built this technology for very low power, for very high reliability, for security, and so forth. And then fundamentally, having this notion of the proximity of things that are around you, whether it's this healthcare stuff or whether it's the lights or the displays or the microphones or the speakers in the room that I might be able to manipulate with my device, the notion of being able to attach to those things easily and understanding, am I supposed to be talking to this device? If the proximity-based service that I'm talking to is a cash register in a store and I want to check out, I really do want to know that that's the right store that I'm paying, and they really do want to know that it's me that's paying it. And so having these kinds of technologies put together, really critically important. Now, some of these services are going to come about initially through entertainment. And at our Analyst Day, we were showing off a thing that we call Jam Join, which is a software technology that uses any peer-to-peer technology that you have. And the idea is I might come in with my phone, my friends might come in with their phones. We'll have one of the phones hooked up to a speaker, and we can each set up a playlist. And they can even look at the songs that are on mine and add songs from my phone to the playlist. They can add their own. We can all control it. So these kinds of things. Now, how does that happen? It has to be done in a way that's very secure, very simple. It's not pairing like bring up a Bluetooth thing and type in the passcode. It's actually the things recognize each other. They have authentication built into them. So this is a critical component. But then going beyond that, we're building radio technologies where individual things will actually beacon out and say, not only do I have a radio connection, but I have a service. I might have a coupon for you, or I might have a connection to the internet, or I might be the cash register that you can check out with, or I might be a display that has a certain resolution, and my phone might say, well, I have this content that I want to, and they'd negotiate, and boom, all this stuff would happen. And the critical issue there is if you're going to wander through the world with your phone sort of looking for services and content, it needs to do it at very low power. So we built new physical layers to do this. The other thing that we built is new user interfaces. So the notion of augmented reality, where you actually put cyberspace things into the view of your camera, and they actually look like they're there because we use image recognition algorithms to actually lock these things into place. And so in the beginning, these kinds of technologies are being used for games. They're being used for advertising now. You pointed at a magazine, and all of a sudden the magazine cover springs to life. But they're also going to be used for giving user interfaces to things that don't typically have user interfaces. People, as an example, don't really have a UI, but you could point it at a person and a little bubble could come up, and I could connect to your Facebook, or I could flick you a picture, or things like that. We actually did a thing with a digital photo frame where you put the photo frame up on the wall and you looked at it and you dragged and dropped pictures from your phone onto the image of this highlighted, glowing picture frame, which wasn't really glowing. It was on the wall, but in the view of my camera, it was locked on there, so it was glowing, and I just drag and drop, and boom, the connection gets made, and that image gets put on the photo frame. So the notion of using augmented reality, merging cyberspace and real space together through the image of your camera and the sensors that are built in your phone, I think this is going to be a fundamentally large application of the sensors and the processing capability and all the stuff that you have. So really to close, just back to this notion of the sixth sense, which really is the bringing together all these things, sensors in the world around us, that kind of computation that we have in the device, connections to the network, to the cloud, both cloud-based computation and local computation. All of these things will come together to allow the phone to be just that much more personal of a device, and really, I think, will kind of merge and blur the notion of what's cyberspace and what's real space, and how do these things all work together. So with that, that's where I think we're headed. Anyways, thanks everybody. Appreciate it.